In this lesson, we are going to go over sequences. This is part 1. Specifically, our objectives are to understand sequences, to find terms of a sequence given the general formula or the general term, and then we'll also learn to predict the general term of a sequence. So first, let's talk about sequences. So a sequence is an ordered list of numbers. So the word ordered is in bold because a sequence like this is different than, okay, even though they may contain the same numbers, it's a different order, so it's a different sequence. Another way to think of a sequence is a function whose domain is natural numbers. So if we take, for instance, this second sequence, our domain, okay, and a sub n, we'll talk about that in a minute, but our domain is natural numbers. So 1, 2, 3, 4, 5, so on and so forth. And then it's mapping to, this is going to 4, this is going to 3, this is going to 2, okay, and it would keep going from there. So for instance, an example of a sequence would be something like 1, 3, 5, 7, 9, 11, and those dots mean that it continues on. You can have a finite sequence where it's just a set of numbers, so it could have stopped at 11, but those ... it keeps going on. Okay, so a general term or a general formula is a way to get any term of the sequence, and so it's denoted by a sub n is equal to 2n minus 1. Okay, and let me go back up to sequence. So this is in the position of n equals 1. So 1 is a term, and it's in the first position. 7 is also a term, but it's in the fourth position. Okay, so this general formula, to show you that we can use the general formula to get to the sequence, let's say you wanted to find the second term of the sequence. So we would plug in n equals 2 to get a sub 2 is equal to 2 times 2 minus 1. So when you say n is equal to 2, you're plugging in 2 everywhere you see an n. Okay, if that sounds familiar, that's related to inputs of functions, and we just talked about that a sequence is a function. So a sub 2 would be 4 minus 1, which is 3, and that is exactly what we have for the second term of the sequence. So let's do some examples. So example 1, find the first 4 terms, a sub 10 and a sub 15, of the sequence with the following nth term. Simplify all answers. So we're finding a sub 1, a sub 2, a sub 3, a sub 4, and then a10 and a15. So in order to find a sub 1, n is equal to 1. So we have a sub 1 is equal to 2 times 1 plus 1, which gives us 3. And the reason that I knew to find the first term n equals 1 is if we put in a 1 here, it would give us a sub 1, which is the first term of the sequence. So we keep going to find the second term. So we have a sub 2 is 2 times 2 plus 1. So 2 times 2 is 4 plus 1 is 5. N equals 3. A sub 3 would be 2 times 3 plus 1, which would give us 7. And n equals 4 gives us a sub 4 is equal to 2 times 4 plus 1, which is 9. So that would satisfy the first 4 terms. To find a sub 10, in order to get a sub 10, you're looking at what value of n you can put there to get a sub 10, and it would be 10. So we have a sub 10 is equal to 2 times 10 plus 1. So 2 times 10 is 21, or 20 plus 1 is 21. And then to get 15, a sub 15, we would plug in n equals 15. So this would be 2 times 15 plus 1, which is 31. So that's the first 4 terms, and a sub 10 and a sub 15. And the reason it says simplify all answers is don't leave your answers for an assessment or for the homework as 2 times 10 plus 1. Actually evaluate that and multiply and add. Next, example 3, find the first 4 terms, a sub 10 and a sub 15 of the sequence with the following nth term. Simplify all answers. So to get the first term, we look at what we need to substitute in for n, and it would be 1. So we do n equals 1. So we have a sub 1 is equal to negative 1. This is 1 plus 4 times 1 squared. Okay. So this is negative 1 to the 5th power times 1 squared is just 1. So negative 1 to the 5th. So it's either going to be 1 or negative 1, and if it's an odd power, it'll be negative. If it's even, it'll be positive. For instance, if I show you, so negative 1, let me just do to the 4th, is negative 1 times negative 1 times negative 1 times negative 1. So that's positive 1 times positive 1. So this is plus 1. but negative 1 to the 5th is negative 1, 2, 3, 4, 5. So negative 1 times negative 1 is 1, times negative 1 is negative 1, times another negative 1 is 1, times another negative 1 is negative 1. So I'm going to be using that. If negative 1 is raised to an even power, it's going to be positive 1. If negative 1 is raised to an odd power, it's going to be negative 1. So in this case, we just get 1. Okay, so n equals 2 is next. So we have negative 1 to the 2 plus 4, 2 squared. So this is negative 1. What is that? 2 plus 4. So that's to the 6 times 4. So this is just 4. Okay, oops, that should be negative 1. The first term is negative 1. Negative 1 to the 5th is negative 1 times 1 is negative 1. Okay, n equals 3 is next. So we have a sub 3 is equal to negative 1 to the 3 plus 4 times 3 squared, which is negative 1 to the 7th, times 9, which is negative 9. Okay, so notice how the first term was negative, the second term's positive, the next term's negative. If it alternates positive and negative like that, it's called an alternating sequence. Next, n equals 4, so we have a sub 4 is equal to negative 1 to the power of 4 plus 4 times 4 squared, which would give us negative 1 to the 8th times 16, so this is 16. So that's the first 4 terms. Now we go to a sub 10. So to get a sub 10, we do n is equal to 10. So we have a sub 10 is equal to negative 1 to the 10 plus 4 times 10 squared, which is negative 1 to the 14th times 100. So this becomes 1 times 100, which is just 100. And then to get a sub 15, we plug in n is equal to 15. So we have negative 1 to the 15 plus 4 times 15 squared. So this is negative 1 to the 19th power. 15 squared is 225. You can do that on your calculator, or you can multiply it out, but this gives us negative 225. So we have found the first 4 terms, and a10 and a sub 15. Next, find the indicated term of the sequence, simplify your answer. So we're given that a sub n is equal to the quantity 3n plus 11 squared. And that semicolon, this means that we are looking for a sub 4. So in order to get a sub 4, we plug in n is equal to 4. So we have 3 times 4 plus 11 squared. You still follow order of operations when you're simplifying. So we do the multiplication inside the parentheses first. Okay, we still work with the parentheses, so this is 23 squared, and 23 squared is 529. Okay, so this would be a sub 4 for this sequence with the given general term. Example 4 is an application problem. It may look familiar because it relates to compound interest, which we've talked about in exponential functions, also in exponential growth, and then it shows up here as well. So suppose $3,000 is invested at a 5.7% interest rate compounded annually. The value of the investment after n years is given by the sequence a sub n is equal to 3,000 times 1.057 to the nth power. Find the amount of the investment after 1, 2, and 10 years. Round your answers to the nearest. The word cent is missing. Cent as needed. Okay. So n corresponds to the year. So n equals 1 is year 1, n equals 2 is year 2, n equals 10 is year 10. So we can plug in n for year 1. N equals 1, so we have 3,000 times 1.057 to the first power. You can plug this in your calculator. Excuse me. So we get 3,171 for the first year. For the second year, n is equal to 2, so we have 3,000 times 1.057 to the second power. And we get 3,351 and if you're rounding to the nearest cent, remember that's the second decimal place, becomes 0.75. In year 10 is n is equal to 10. And we plug that in as well. So this gives us $5,222.41. Okay, so that would be the investment. The last thing that we'll talk about, we'll just do one example, is predicting the general term. So In the previous examples, we've been given the formula for the general term, and we can find whatever term it's asking us for. Now what we're going to be given is the sequence, or part of the sequence rather, because it's infinite, so we can't write it all down. Part of the sequence, and we're going to be asked to predict the general term. And the reason we're predicting it is because it's not for certain. We don't know what the sequence does later on. It could do something maybe we're not expecting. But using the first several terms that it gives us, we're going to make a good, educated prediction as to what the general term is going to be. So for this example, predict the general term, or what's called the nth term of the sequence. So we have 8, 16, 24, 32, 40. So when I'm doing this, my suggestion is to just take a look at any of the patterns you see. So for instance, the first thing that jumps out at me is we add 8 to get to each next term. Okay, so every term is increasing by 8. The other thing that's helpful to do is write out like the n value, the term, what position it's in, and relate it to the value or the term. So 8 is n equals 1, 16 is n equals 2, 24 is n equals 3. Okay, and if you notice, the first term is 8 times 1. The second term is 8 times 2. The third term is 8 times 3. The fourth term is 8 times 4. And the fifth term is 8 times 5. So if we carry this on, the next term is probably going to be 8 times n. Okay, so our general term here, what we're predicting is 8n. Thank you for watching. If you have any questions, feel free to reach out to me.